Let's talk about one of the most important upgrades in the history of the internet, one that you've probably never even thought about. It's the story of the invisible architecture that keeps our digital world online and, more importantly, keeps it growing.
So let's just start with a kind of scary question. What if the internet just ran out of room? I mean, no more space for new websites, no new smartphones, no new anything online. Sounds like science fiction, right? Well, for a while there, this was a very, very real problem we were hurtling towards. And to understand why, you first have to get what an IP address is. The easiest way to think about it is like a mailing address for your house, but, for your phone, your laptop, even your smart toaster. Every single device that connects to the internet needs one of these unique addresses to send and receive information. So where did these addresses come from? Well, that story takes us all the way back to the beginning, to the internet's original operating system. Meet Internet Protocol version 4, or as pretty much everyone calls it, IPv4. This was the OG workhorse that got the whole internet off the ground. It was designed in an era of computers the size of a room, long before anyone ever dreamed of carrying the entire internet around in their pocket. And at the time, its capacity seemed almost infinite. IPv4 offered about 4.3 billion unique addresses. Now, back in the 1980s, that number felt astronomical. It really seemed like we would never, ever run out. And its format is probably one you've seen before, especially if you've ever poked around in your home Wi-Fi settings. It's that clean, simple set of four numbers separated by dots. It's super easy for us humans and computers to read. But that wonderful simplicity, well, it came with a hidden limit. And that limit was about to create a massive problem for the entire digital world. See, the internet started growing way, way faster than anyone had ever predicted. All of a sudden, it wasn't just about a few computers and some universities. We're talking billions of smartphones, laptops, smartwatches, smart TVs, you name it. This absolute explosion of devices created a kind of digital land grab, and we were running out of those 4.3 billion addresses, and we were running out fast. The internet basically needed a bigger foundation. It didn't just need a patch or a quick fix, it needed a complete architectural overhaul to get ready for the future. And the answer was Internet Protocol version 6, or IPv6. Now, this wasn't just some minor update. It was a brand new system, designed from the ground up to solve that address shortage problem permanently. So, how many more addresses does IPv6 give us? Okay, get ready for this number. It's 340 undecillion. That's a 340 with 36 zeros after it. It's a number so ridiculously vast, it's hard for our brains to even comprehend. To put it another way, it's more addresses than there are atoms on the surface of the entire Earth. Yeah, we are not going to be running out of these anytime soon. So this slide really breaks down that fundamental shift. IPv4 used a 32-bit address. That's what gives us those 4.3 billion combinations. IPv6, on the other hand, uses a 128-bit address. And that's the key to that absolutely insane number of addresses. You can also see the format changed, from that simple dotted decimal to a more complex but way more capable hexadecimal system. But here's the kicker. Solving the address problem wasn't the only goal. The engineers who designed IPv6, they took the opportunity to make the whole internet just work better. So, IPv6 came with some really serious upgrades. It actually simplifies how data packets are labeled, which makes the whole process faster. It also has much better security features built right into its core. And it allows for more efficient routing, which means data can find its way across the internet more directly. So it's not just a bigger internet, it's a smarter one too. So why does any of this matter to you? Because this quiet, totally behind-the-scenes upgrade is what's making the entire future of technology even possible. Think about it. Every single smart device, from your thermostat at home to all the little sensors in a fully connected smart city, every single one needs its own unique IP address. The practically infinite pool of IPv6 addresses is the resource that allows the whole Internet of Things to actually exist and grow. And that's really the key takeaway here. While you might never see or type an IPv6 address yourself, this silent transition is the reason our digital world can keep expanding without hitting a wall. It ensures that innovation isn't going to be held back by a lack of digital real estate. So, we solved the problem of